We are Team Gargoyle. Our team name captures the spirit of our Hacking for Defense challenge issued by the Joint Improvised Threat Defeat Organization of the United States Department of Defense. Our challenge asked how we might use augmented reality for U.S. security elements in order to identify threat individuals in crowds in unstructured environments using facial recognition. Alongside the challenge, JIDO asked us to investigate wearable tech options integrating augmented reality and facial recognition technology that can achieve certain specifications. There currently are many challenges within physical security for both military and civilians, as demonstrated through tragic events such as the Boston bombings. Given these challenges, Team Gargoyle sought to understand how the nexus of augmented reality and facial recognition might be combined with cutting-edge technologies and wearable tech in order to mitigate threats. The benefit of wearable tech is that it allows users to be mobile and hands-free. Team Gargoyle was able to test smart glasses because JIDO had recently acquired gARGoyleH4D glasses. Team Gargoyle's process to solve our challenge was to get out of the building, using Lean Startup method as a guide for our process. We tested our hypotheses by interviewing people, visiting agencies, and finally testing the R7 glasses technology. Our first hypothesis that we tested was to see if beneficiaries have a capability gap requiring a solution with augmented reality and facial recognition technology. We spoke with potential beneficiaries, including law enforcement, force protection, Transportation Security Administration, and analysts to understand the pains and gains of their daily job. From this process, we learned that end users want a solution that is lightweight, easy to use, and hands-free. We also learned that the solution might not align with the mission of certain end users that are operating in unstructured environments. When conducting our customer discovery process, we also learned that there are privacy and legal concerns that exist for government use of facial recognition and other biometric technologies within the continental United States. Unlike private and commercial sectors, government has many concerns over privacy and abuse of information. Ironically, there is no regulation over these same concerns in the commercial sectors, where consumer information is used all the time as part of personal advertising and customized marketing campaigns. In light of the privacy and legal challenges in the continental United States, in Week 8 we pivoted to focus our operations OCONUS. We also decided to focus on structured environments such as forward operating bases, combat outposts, and checkpoints due to telemetry and mission fit problems in unstructured environments. We decided to model our value proposition canvas based on military police, as they are regularly tasked with screening individuals entering bases. We sought to understand whether a smaller database loaded onto a commercial off-the-shelf product, such as the gARGoyleH4D glasses, could allow for better accuracy of facial recognition technology. We imagined an end user loading a high-value target or be on the lookout list onto the glasses. Using Image's facial recognition technology integrated within the R7 glasses, we created our own database and tested the facial recognition speed, precision, and distance at which the face was captured. Indeed, our own tests on the gARGoyleH4D glasses yielded depressing results for the capabilities of the glasses to recognize and identify faces beyond 6 feet. In addition to other user pains, such as short battery life, the device not being truly hands-free, and the impact of the weight and heat of the device on the face when worn for long periods of time.
Wearing the glasses for about 10 minutes and they're already very hot.
To achieve our intended result and meet JIDO specifications, we determined that the best MVP is to use a layered approach whereby the wearable device is a component in a system of stationary video cameras and a computer. Using a layered approach, a telephoto lens on a stationary camera can capture an image at a distance of up to 100 feet and send this image to a desktop where an analyst monitoring the computer will look for matches within the database. If matches are found, the analyst will determine the location of the individual or individuals using GIS software and send the coordinates to a guard wearing an augmented reality device. The guard will then be alerted of the location and information of the person of interest using augmented reality. Overall, this layered approach will maximize the potential of augmented reality and facial recognition to identify threats before it's too late.